All right, so there were 29 that you did. How many of you got 15 or more correct? 15 or more. Okay. That's about our goal right now, is to try to get over half of those. All right. So kind of judge where you are based on that. All right, we're gonna have to go through these quickly. I do want to answer ones that I feel like you need help with, but if there's some that you're like, you know what, I missed it, but if I looked at it, I bet I could figure out why I missed it. We're gonna have to hold off on those. All right. We'll just go through this quickly. 1 and 2, you're responsible for. You should know how to do those. All right, 3 or 4. Any questions on 3 or 4? All right, 5 or 6. Just a quick reminder, guys. Cell phones out of sight. Please don't be pulling them out during class. I know some of you are like trying to be whatever. Just out of sight. Put them away. All the way away. Yep. Cool. Let's get something out. All right. Notebook, whatever. Yep. From here on out, here's what I'll say. We have, today is April 11th. Your test is in less than a month. Okay. We have review time. Don't get lazy. This is your review time. Here's what I will say. This review time is not for me. All right. From here on out, like I've taught you every section we need to cover. Every section. I am not teaching you any new material. This is all review. I don't have to do this. How many AP classes are you guys starting to review? Like, what other classes have you started reviewing? Lit? Physics? So we're already through all the content reviewing. Okay? Here's what I will say. Don't take it lightly. Don't say, okay, this is review time. Let's just sit back, relax, and take it easy. All right? You need to buckle down and chip away at these to get the best score you possibly can. You are saving yourself so much time and money. I cannot emphasize that enough. And the only reason I'm spending so much effort and time and whatever is because I want you to do well. It's nothing like I don't get any sort of like pay raise or bonus or like whatever personal reward if you do well on this. All right. There's no reward in it. I literally want you to do well for you. Okay. Like I have seen the reward individually for students by doing well on this and the amount of time and money it saves them that like I take this very seriously. And so I want you to as well. All right. And that's just not just this class, all your classes. All right, do that. Don't say, just kind of whatever. It's a month left. It's just I don't really care anymore. Like don't go there. All right. Wendy.
When's our review session before?
Yeah, it's this Wednesday, I believe. The 13th? 11, 12, 13. Yep. It's this Wednesday morning. It's 2 hours. What time did your other one start? Like 7:39? Is that when they start? So I still am trying to figure out where we're going to be because we're one of the bigger ones. We have 48 Calc students, so I'm guessing rooms A and B. We'll talk about. I mean, you're only going to have to bring your calculator and notebook and pencil and stuff. But here's what I'll say: this test is one of the longer ones. Like it's pretty grueling. Like just to be honest with you, there's part A multiple choice, there's part B multiple choice, then there's the 2 free responses, and then 4 free responses. It ends up that students get out around sixth period, like sometime during sixth period. It's a long test, okay, and there's no way in a 45-minute, 48-minute class, whatever they are, that I can simulate a 4-hour test. It's just not the same. Like if I say, hey, we got class time today, let's work through the multiple choice, like that is totally different than having chunk of time work. Okay, here's the next test. Boom. And then short break. Next test. But like there's something to be said for being able to stay mentally like focused for that long. And so during the AP review session on Wednesday, we are going to take a chunk of a test. I'm still trying to decide what the best one is for us right now. But I want you to see what it feels like to take like half the test and to be able to have a strategy. Okay. Because it's kind of rare that like any sport you play, what do? You train and then like let's say there's I know I coach tennis, but let's say there's a 3 hour tennis match that you could possibly play in. Do you think a 30-minute practice is going to prepare you physically for? No, it's not. And if we kind of look at this the same way, like when you train for a run, you train for a marathon, you train for whatever. Okay, there's a strategy there to prepare you for the longevity it takes to get through that. And part of it is getting like having a chunk of that to see what it feels like, so that when you're in the actual one, you can say, "Oh yeah, like it's okay. I've gone through this kind of thing before. I don't need to get everyone right. I need to get this number right. And if I can stay above this percentage, I'm not going to get down on myself." Like having that kind of self-talk as you're going through it, that we're going to try to simulate a little bit of that on Wednesday. Sound good? All right. So that'll be Wednesday. I do want to have, we'll talk about food and so forth for planning purposes. Do you guys want to have food on Wednesday morning? You want to do that? We typically would celebrate Pi Day like March 14th, and I told you guys we'll hold off until AP review. There will be some food restrictions based on some allergies, but is tomorrow too short a notice, or is that all right if we talk about that tomorrow? Is that all right? All right. Cool. Did I answer your questions? Is that right? Did I answer all of them? Kind of went off a little bit there. Any questions on 5 or 6? I don't want you to be shy and not ask questions if you have them. All right. So don't just think we're not going to go over any of these. Did you read number 7 and did it resonate with you? Hey, when I read the words total area, I need to do something different. What's total area? And I'm sure you imagine me walking in the front of the room. Oops, never mind. I read that wrong. I should have read the whole question. Total area between curves. That's a different application. I thought it was going to give you a velocity graph. It didn't. All right, I'll take that back. Total area between curves is just top minus bottom. All right, or right minus left. But I guess the one I was thinking, I was asking in that context was, what if it says, what is the total distance traveled or the total area from blank to blank? Like, you need to take that negative area and make it positive and then combine them, right? Total distance traveled. 8. How is 8? Questions on 8? Nine? You probably didn't know what the graph of absolute x over x looked like unless you kind of modeled it, plugged in some values and modeled it. That's what I did there. Okay with that one? 10? That was a tricky U substitution. Kind of tricky. Need it explained, or are you okay with that? All right. All right. I did 11 a little differently than maybe some people did. Question for you. I'm going to get rid of the highlighting here. I don't know why. I have some ideas, but I don't know why our eyes are drawn to the wrong area here. Like, if I were to say find the integral from 2 to 12, do you agree that if this is f of x, the integral from 2 to 12 would be do you agree it would be that area? Everybody with me there? Our eyes, what do our eyes get drawn into? The semicircle, right? I mean, we're just so used to seeing circles and areas of circles and all that. So our eyes get drawn there. The red is what we actually want to find. The graph of y equals f of x consists of a semicircle with endpoints 2, -6, 12, -6 as shown on the figure. What is the value of the integral from 2 to 12? We're trying to find that red area. Do you agree maybe the better way to do this, or the only way, is to find the area of this blue rectangle, take away the area of the semicircle, and you'll be left with the red area. Everybody okay with that? $12 or $13? Any questions on 12 or 13? No problems with 12, because you guys really struggled with 12, like problems like 12 earlier in the year. All right, Wendy?
Can you go over 14? Because I missed I had the right derivative, but like the wrong side.
All right, so dy dx. They asked us for the third derivative. So first derivative, what's the derivative of cosine x? What's that?
Negative sine.
Negative sine x, good. Minus, what's the derivative of ln of 2x? Well, it's 1 over 2x times 2. So 1 over x. 1 over 2x times 2. Good so far? Second derivative. Well, the derivative of sine is cosine, so we have negative cosine x. The derivative of 1 over x, I wouldn't do a quotient rule. I'd bring it up as x to the -1. The -1 comes down, and then x to the -2. So at -1 and that negative make a positive 1 over x squared. Good so far, Wendy? And then the third derivative of cosine is negative sine. So positive sine of x. This is x to the -2, -2x to the -3. You can see that. What was the answer here? Was it letter A? Make sense? questions on that one? Kylie, you want to say one?
Yeah.
All right. The graph of the function f, as shown above, consists of 3 line segments. The function g is an antiderivative of f such that g of 2 is 5. For how many values of c does g of c equal 3? All right, so Kylie, here's the way I thought of it. This is a fundamental theorem of calculus question. So, if this is f, Kylie, help me out. From 0 to 2, if f is above the x-axis, what is g doing? Do you know? It's going up or down? G's going up. Good. Right? If velocity, position, velocity, acceleration, okay, you're like, I was hoping you'd walk today. If this were a velocity graph, the velocity is positive, but getting close to 0. So my object is moving to the right or up, whatever the direction is, okay? From here to here, it's moving up. What's moving up? The antiderivative function, right? Ready? Velocity, the position function is moving to the right or moving up. Are you with me? Well, how far did it move up from here to here? Well, whatever the area is of that triangle, it moved up that much. So the area of this triangle, it's half of 2 times 2. It's half of 4. So this area right here is 2. And it told me at 2, if this is the f function, it told me g of 2 is 5. Ready? G of 2 is 5. This blue graph is the g graph. If g of 2 is 5, what was g of 0? 3. Why? It just went up 2. It must have been at 3 2 units ago. With me? G of 3 must have been 0. What's g of 5? Well, is it going to be lower or higher than this value right here? Yeah, because if f is negative, isn't g going down? How much? Well, base 3, height -2, area -3. So I was at 5, now I'm at 2. This blue dot was just a reference dot, not a point. Do you agree? You with me so far? Okay. Then what? From 5 to 6, did g go up or down? Up. Good. And this is 1. This is 4. Half of that is 2. So it went up 2 units. So it went from 2 up to 4. So g of 6 is 4. Now, I don't know what g looks like, but if it's a connected graph, it could have been something like that. And they're wondering, how many times did g cross through the horizontal line of 3? Well, once, twice, 3 times. That's the way I thought it. I thought of it kind of graphically. Did anyone think of it differently? Does that make sense? How many of you did it the way I did it? No one. How many of you got it right? No. Guessed? Casey, do you know how you got it right, or just?
Yeah, I'm guessing that I guessed because I don't know anything written down.
Gotcha. That was a tough one. Does that make sense? Now, be honest with me. Okay. Thanks, Kylie. Thanks for asking that, because it seemed like a lot of us struggled on that one. How do we do on 15? This looked like straight out of a quiz we did early in the year, long time ago. Okay with that? Slope fields. How do we do on 16? All right. How many were you able to eliminate right off the bat? Of the 4 options, you're able to eliminate 2 of them? Okay. And then what was the nail in the coffin for you? Like how did you finally narrow it down to the final answer? I want to hear more from you guys since you're starting to interpret this stuff and understand it in context. Dom?
I've narrowed it down to A and B, and then A in the second quadrant, the slopes are negative, and they won't be negative because it's x squared plus y.
And a positive y. Good. Yeah, I like that. You see what you already said? Thanks. All right, this one, I took that y equals equation. I'm guessing you want to talk about this one. Okay. Do you agree this y double prime is a symbolic? Like it's saying, here's y double prime. I'm not telling you what y double prime is, but whatever it is, it goes there. Okay, like, here's what I did. I found the y prime of this equation, and I found the y double prime of this equation, and I inserted them into the format they had here to see which one matched up. If that makes sense. Because all of the answers looked pretty similar. So I was able to see that was y double prime minus y prime minus 5. Wait, minus 5. Hold on a second.
You have to distribute the 3 and y prime.
Yeah, plus, that'd be plus. And which one?
I had the 3 on the outside of the parentheses and y prime.
Oh, you mean to test it? Hold on a second. Minus 3, minus 15. This was my work from before. I better just do it because I'm not seeing what I did there. Was the answer A? Okay. So to test A, we would see if 9e to the 3x, that's y double prime, minus 3e to the 3x minus 5 minus 15 equals 0. So this is a test. I'm not saying this is a true statement, but if A is right, it needs to satisfy this. Do you agree? So 3, it would have to have a 3 there for this part to be correct because we're doing minus 3 times y prime minus 15. So minus 3y prime minus 15 equals 0. All right. So we have 9e to the 3x minus 9e to the 3x plus 15 minus the 15 that's here equals 0. So 9e to the 3x minus 9e to the 3x equals 0. And we just test, is that a true statement? Yes, that's a true statement. It took that 3 out front to make that happen, correct? And so does that make sense how I inserted y double prime and then the 3 from that one with the y prime minus 15 equals 0? I laid it out. anytime you see a which of the following, you're going to have to test the options to see which ones work and which ones don't work. So quick little rundown. Since I tested A and it worked, what would be wrong about B? Well, that plus 15 here, it would have been a plus, in part B it was a plus 15 here. It would have been 30 equals 0, which is not true, and that one would be false. In part C, there's no 3 here, and so it wouldn't cause it to be 0 there either. All right, how was 18? All right, but that's one you guys could figure out if you missed it. How was 19? How many of you got 19 right? This is a long time ago. Raise them high. 1, 2, 3, 4. All right. Need to go over it? Did you recognize this? We learned a couple variations of this year. Limit as h goes to 0, f of x plus h minus f of x over h, yes? We also learned the limit as x goes to a of f of x minus f of a over x minus a. This was called the formal definition of a derivative. This is called the alternate definition of a derivative. I would highly encourage you, okay, if you're like, I want to do well on the AP test, I want to do everything I can, you should already have a page dedicated to AP review in your notebook. Like either, because let's be honest, once this packet's done, you're probably going to put it away and forget about it, okay? I would probably have a page in my notebook that, if I don't have it yet, AP review, and I would have things that I totally forgot that I want to make sure I study again and remember, okay? This would be one of them. You're going to see this on the AP test. Guaranteed, you will see one multiple choice question like this. Now, do you recognize this limit question as a derivative problem? Silence. Okay. Do you need me to do a quick review? Quick limit review. Are you ready? The limit as x goes to 2, x squared minus 4 over x minus 2. This was the foundation of calculus for us. I used this idea to introduce a new word to you. It was like second week of school. And then we built everything off of that. How do I evaluate this limit? Step 1, plug it in. 2 squared minus 4 over. Uh-oh. 0 over 0. We learned a new word. It was called indeterminate. Try some algebra. Factor, cancel, limit. By the way, is the limit still going to exist? Is the limit still going to exist if you get 0 over 0? Yes, it's going to be a whole. The limit still exists. Remember that? Vertical asymptote? No. No limit. X plus 2, x minus 2 over x minus 2. Remove the discontinuity. Plug x in. And you get what? 4. What does 4 mean? This is not a slope. We didn't get to slope yet at this point. That was the limit as x approaches 2. What is a limit? Make me proud. What is a limit? It's not a slope. It's a y value. It's an intended height of a function. What's the graph? What does the graph of this look like? Nope. What does the graph of this look like? Cool.
The graph of x plus 2 is
It-
a line.
It's x plus 2. X plus 2 just looks like that. But wait a minute. At 2, there is a hole, a removable discontinuity. What's the height at that removable discontinuity? 4. 2, 4. 2, 4 is the intended height of the function. Remember the spiders? Did I do spiders this year? No? Oh, sad. Yeah. As the spiders are on the function approaching an x value of 2, they have to like be on the line. And what are they approaching? They're approaching a height of 4. Right? That's the intended height of the function. That's a limit. Did I say anything about slope there? No, a limit. Intended height of the function. Okay? Then, what did I do? Well, I said, hey, you're driving home from school today. You're going down Lake Center. Run the S-curve. You got home in whatever time. Your mom said, hey, you're going too fast. You're like, oh, I averaged 40. But then as she narrowed down the time interval, you had a location, but you also had a speed, right? So if we want to find the speed of something, don't we have to use slope? Wasn't this a y2 minus y1 over x2 minus x1? F of x plus h minus f of x over x plus h minus x, h. y2 minus y1 over x2 minus x. This is now a slope. It's a limit problem. But what's the setup of the function? It's not just f of x. It's a slope setup. Does that make sense? Yes? So when you find the limit of the slopes, now you find a derivative. You find the limit of the slopes. Here's a graph. This is f of x. If I say, how fast are you going here? I'm not finding out how high it is. I'm finding out how steep it is because it's a slope setup now. That's going to be negative, isn't it? The slope, negative. Height, positive. Slope, negative. That's a derivative. So this, yes, this is a limit problem, but they're not trying you to see the limit application there. They're trying to get you to see, hey, this is a slope. This is a derivative. It's a y2 minus a y1 over x2 minus x1. What's this? F of x minus f of a. y2 minus y1 over x2 minus x1 as x goes to a. Well, what did that look like? Well, this is now a. Ready? A. X. What's the height here? F of x. F of a over x minus a. y2 minus y1 over x2 minus x1 will find the slope, but I don't want that slope to be 2 points really far away. I want to move x closer to a. Okay, secant slope. Okay, secant slope. Okay, tangent slope. Do you remember this? These are both derivatives. Back to the story. They want you to recognize this as a f of x minus f of a over x minus a. And I notice that because I don't see an h go to 0 or an x go to 0. I see x going towards e, meaning we're finding the instantaneous rate of change of f of x when x equals what? E. when x equals e. So how do I write that? Like, I don't want to, honestly, I've told you this before. I see that they want us to use limits. Don't fall into the trap. How do I write this with new notation? Not limit notation, that was old school. If f of x equals blank, they're really asking me to find f prime of e. Aren't they asking me to find the derivative at e? Be honest with me. Do you see that or no? Well, what's f of x? Can I find out what f of x is from this setup? Yeah, it's f of x minus f of e over x minus e. What's f of x? X to the 20th minus 3x. What's f prime of x? 20 x to the 19th. What's f prime of e? 20 e to the 19th. What are we missing?
Minus 3x.
Oh, thank you. I wrote that wrong. I put minus 30. It was minus 3x, wasn't it? My bad. Uh, 20x minus 3. So this is minus 3x, so minus 3. 20 e to the 19th minus 3. Does that make sense? Be honest. Was it B? I don't have the answers in front of me. All right. This test, it goes to another level than just, hey, here's a function, find the derivative. Okay? It's not that kind of test. It's very conceptual, very analytic. You have to interpret. Now, good news, they only have so many ways they're going to ask you the question. And I've seen this every single year. I could open up every year that I've seen and find one problem where they set it up like this, and they're like, hey, student, this is a derivative problem in disguise. Don't use limits. Don't fall into the trap. All right? Set up that way. Now, I'm curious. It just kind of dawned on me. By the way, I should have done what I always tell you. What should I try to do first? Plug in e, right? E to the 20th minus 3e. Okay, 0 over 0. Did anybody do L'Hopital's rule on this one? Did it work? Okay.
I was saying I got 0 over 1.
Okay. 20x to the 19th minus 3. 20x to the 20th minus 3. Hold on a second. What's the derivative of the numerator? 20x to the 19th minus 3, right? This will all go to 0. That's all constant. Over, what's the derivative of the denominator? 1. Plug in E. L'Hopital's rule. When do you use L'Hopital's rule? When you try to plug in the limit and you get 0, 0, or infinity of infinity, right? Good recognition, though. Where did it go wrong for you? Just curious.
I took the derivative of e to the 20 minus 3. I didn't see it as a constant.
Yeah. Makes sense. Makes sense. Good try, Madison. All right. Here's what I want to talk about for the rest of the time. All right. We have an agenda for this week. And it's going to involve some independent work for sure. Okay. Now, you guys have a benefit. You're going to be in here the full class time tomorrow and the next day. All right. Monday, we went over most of the 1 through 30. All right. All of this is due by the end of class on Thursday. We do have a quiz, a Canvas quiz on Wednesday. We'll talk about that in a minute. You have the 2016 packets. You're going to do 1 through 4. Allow 15 minutes per free response. Now, I'm not saying set a timer unless you want to. That's up to you. Okay? 15, 30, 45, 60. There's an hour. Okay? Right there. Unit progress checks on AP Classroom. I've assigned Unit 1A and 1B and 2A and 2B. I need your help. I think we've already done one of the, I think maybe we've done one of each of these this year already. I wanted to assign it to you again for review because it's been a long time since we've done limits and stuff. If you could check on those tonight for me, AP Classroom, make sure that those are assigned properly to you. I don't do this all the time. Help me out in that respect. Okay. Videos. I reviewed this way last year and it went really well. Okay. Now it's going to take some dedication on your part and you have to say, I'm going to do my best on this because it's the best thing for me. All right. If you go into AP Classroom, do you guys know where the daily videos are? Do you know what I'm talking about there? They're called AP Daily Videos. I would highly recommend we're going to do this a couple weeks in a row. Pick 4 daily videos to watch. They're not long. All right. I've even assigned some of them to you when I was absent this year. All right. Pick 4 daily videos. You're going to take notes on them again. So if you forgot how to do the limit definition of a derivative, you might want to go back and find an AP Daily video on limits or limit definitions. Okay. You're going to take notes on 4 of those videos in your notebooks. You're going to take pictures of the notes. You're going to upload the pictures to this link on Canvas at the end of the week. Oops, I clicked on it. The 1 through 4 on 2016, you're going to upload pictures on this link on Canvas. Those are points for the week. They're due Thursday at the end of class. On Wednesday, we're going to take a 10-point summative free response quiz. It's an AP free response problem. It has to do with a table of values. So X, and I'm not going to tell you what the dependent variable is, but you may be asked to use Riemann sums. You may be asked to find the instantaneous rates of change. You might want to review that before Wednesday. So what am I saying? This is your stuff to do for the week. It's due Thursday. You're going to have some class time, but I would recommend getting a start on it tonight. Okay? I'm hoping to pass the quizzes back to you tomorrow. If everybody's taking them, everybody from this class is taking them, I think we're in good shape. Any questions about what's expected? Send me an email if something doesn't open up properly if I didn't assign it. Yeah, do you have a minute? Yeah.